Hello, this is Glenn Broderick from Vitrek, and today we're going to take a look at the Vitrek DLx series of loads. We have 6 of these in a family, and we can go up to 500 volts. We can go down to 0 volts, which is an unusual capability. This load is architected differently than a lot of the loads you've seen in the past. To begin with, we have a color touch control screen here, which allows us to do a lot of things you normally can't do with a load. So I'm remoting into the load because it also has a web interface. I just gave it the IP address, put it on the right subnet, and now I'm controlling this from my web browser. So you've seen loads before that have constant current control. That's good. They've got constant voltage control. This one also has constant resistance and constant power, resistance in watts, okay? But something probably a little more different is that we can actually do all of them simultaneously. So what this allows us to do is you set up your constraints, and then you can test your test article anywhere within those constraints and make sure it works properly throughout the curve of where it should be. I'm going to turn those off. Now, you also have the ability to go in and not only that was the basic, we were just looking at the basic setup, that's real easy, but you can go in and put a table and you can have it step through whatever you want. Same with arbitrary, we can sequence based over time. This is by voltage. And we can also sweep, so sweep through your different ranges just to make sure everything's working properly. Now, a lot of people work programmatically and they don't want to have a technician walk over and open, add leads or disconnect leads. And so programmatically, we can open the load, we can short the leads. We also have overcurrent protection and overpower protection. So those are some of the basic loading parameters. Now, in the basic mode, I can have 2 profiles, an A and a B. That's how I turn on B. And I've told profile A to load at 1 amp constant current and stay there for 1 millisecond, and then load 100 microamps 1 millisecond and stay there 1 millisecond. Okay, so that's how quickly we can change. Before I start my test today, I'm going to go over, I want to do a quick start and a self-test. So what I'm going to do is I'm going to disconnect the load right here, and I'm going to say start. Okay, and that's it. It takes about 15 seconds. It's a good way to start the day. You know everything's going good. This is the most accurate load on the market. It's an unusual design because it's range. There's no ranging. There's only one range, basically. So what that means is there's no discontinuities in your data as the system switches from one range to the other, because we don't switch from one range to the other. So once you're ready to do your test, we've set it up. You can go over to your general. There's actually some more parameters in here you can take a look at. Change limits controls the rate of change. You can specify a filter in microseconds or a slew rate in current per microsecond. And we can also have a simulated inductance. And so this basically slows down the rate of change of the current through the device. And we can set trip limits for upper voltage to protect your device. You can specify that limit. And we also have a soft start. Soft start basically brings the load up a little slower so that you don't shock the test article. And we can specify all the parameters here. We also have a battery test mode. And in battery test mode, you turn it on and you can establish a threshold. Essentially, when you do a battery test, this is going to use the data logger to show the charge or discharge of the battery. And when the voltage gets down to a certain voltage, then it will stop the test automatically, or when it gets to a certain time, it will stop the test automatically. So that's how you do battery test. There's also the ability to control the number of digits in here. I like to leave them all on because this is a nice steady display. Profiles allows you to save and recall setups. Obviously, this whole thing's programmatic, so you can control this from an LXI type of interface. And you can, in data logging, here's your controls. You can truncate the data so you don't have all of it. You can synchronize the data. You can timestamp the data. You can append it so that this test gets appended to the last test. You can do continuous data logging, add a heading as an example, give it a file name. These are all your controls for DC loading. Now, once you have this thing set up for testing, you turn on your load right here. This basically connects it up, and I'm going to turn on my DC current source. And there you'll see that we are switching from A to B. When it's in the A mode, it's a 1 amp load. When we're in the B mode, it's a 100 microseconds. And there's the actual voltage and current and resistance. So the other thing is this is real time. So this is the average. You've got these 4 meters in there, but you can actually time it so that you're only looking at the A phase. And so here you are, when in the A load profile, it's drawing 1 amps. And if you go to the B, you can see that in the B load profile, we're drawing 100 milliamps. So that's right where we're supposed to be. I'm going to go back to real time because that's what I'm used to looking at. So remember that this also has an oscilloscope inside. And so we have the ability to put voltage or current, power or resistance on the oscilloscope. There is a cursor that we can pull out and we can put specific spots and look at it. The advantage of this oscilloscope is that you don't need a double load because it's already connected up. So you don't load your circuit and throw the measurements off. Notice that when I change something, like if I took this from 20 to 50, your data is still there. And the reason why the data is still there is we're always storing data all the time. And so even if you rescale it, we're just displaying it differently, but you don't ever need to go redo your test a second time. So that's your oscilloscope, your cursors. There is also the XY mode, which is what we call a Lisa-Jus. I can put whatever I want here, watts, current, resistance, voltage on any of these, and then I can look and see where it's hanging out most of the time. So that's part of why I do that. In the history mode, it's data logging all the time. Notice that we've been data logging the whole time we're talking. I can scale everything. I can adjust it up and down. We are plotting the voltage, the current, the power, and the resistance all simultaneously. So that is the history mode. And there are other things that you can do in here, but this is just going to be a quick demo. If you have any questions, feel free to contact us, and thank you very much for sitting in.